All right, everybody. So we're going to look at solving an absolute value integral. So just a quick review of what the absolute value function is you've learned, well, f of x is equal to the absolute value of x, these two solid lines here, which means anything inside of it becomes positive. So if I have the absolute value of -4, that gives me 4. The absolute value of 4 is 4. Now, you may have seen one of the actual definitions of the absolute value function. There's a couple, but the one we're concerned about is defined as negative x when x is greater than 0, not less than 0. When x is less than 0, and it's x when x is greater than 0. So what that means is if I'm putting -4, I look at this piecewise function here. -4 is less than 0, so I put it into this function. So you end up with negative of -4. That's why I get a positive answer. If I put 4 in, 4 is bigger than 0, so I put it into this x, so I just get 4. All right, there's no negative. But this bit, this negative x, when x is less than 0, is why everything becomes positive when you plug it into the absolute value function. Now, how do you get, one sec, where does this number come from? This number right here, x is less than or greater than 0 in this case, is what makes the inside of the absolute value 0. So if I define my function as the absolute value of x plus 1, okay, that is going to be, well, what makes the inside of this 0 is -1. So we're going to have 1 when x is greater than -1, which will be consistent and do the less than on top. When x is less than -1, and one side is when it's greater than or equal to 1, and that should be greater than. Okay, so when it's less than 1, when it's the negative part, it's negative absolute value of x, so negative x plus 1. And when you're greater than 1, it's just the function inside, x plus 1. Okay, so let's look at the integral, the absolute value. So we define f of x to be the absolute value of 2x minus 1. Oh, one other thing. Let's talk about the absolute value graph. Graph of the absolute value function. Hopefully you remember from math 12. Looks like that. In this case, that's an h value of -1, so it's been shifted over -1 units. So it looks like that. So now we look at 2x minus 1. Well, what makes the inside of that 0? That's going to be, if you don't see it right away, you can just do the algebra. 2x is equal to 1, x is equal to 1/2. So that means you can rewrite that function as the negative of 2x minus 1 when x is less than 1/2, and it's 2x minus 1 when x is greater or equal to 1/2. And if you look at the graph, what makes the inside of it 0, the 1/2, is your shift. So that's 1/2. So now the graph looks like that's the graph. So if I say, what is the integral from 0 to 2 of 2x minus 1 dx? That is saying, what is the area under that curve between 0 and 2? Well, 0 is there. We'll call 2 out here. It's probably further. That's okay. So I'm looking at all that area. Well, this part of the line here is when x is greater than 1/2. So it's that function. But this part of the line, that's when x is less than 1/2. So it's actually this function. If you multiplied that negative in, you'd get -2x plus 1, which means you have a y-intercept of 1 and a negative slope of down 2 over 1. Okay, so that's why the line goes that way. Because it's defined as two different functions, piecewise, we have to break up the integral. this area is going to be this area from 0 to a half plus the area from 1/2 to 2. But those are two different functions, so we write the integral from 0 to a half of the negative bit, this bit of the graph, negative 2x plus 1 dx plus the area from 1/2 to 2, so all that stuff, and that is 2x minus 1. So now we just solve the integrals. So the antiderivative of negative 2x plus 1 is negative x squared plus x, evaluated from 0 to a half, plus the antiderivative of 2x minus 1 is x squared minus x, evaluated from 1/2 to 2. And now we just plug everything in. Negative 1 over 2 squared plus 1 over 2 minus, if you put 0 in, everything disappears, so I'll just write 0, plus this bit, 2 squared, not over anything, 2 squared minus 2 minus, and then you plug in the 1/2. 1 over 2 squared minus 1/2. Okay. This gives me negative a quarter plus a half. That goes away. 2 squared is 4 minus 2 minus 1/4 plus 1/2, because that negative gets dumped into both of those. Negative a quarter and negative a quarter is negative 2 over 4. A half and a half is 1. 4 minus 2 is 2. So this gives me 3. 2 over 4 is a half. So 3 minus a half, if you want to do it as fractions, is going to be 5 over 2, or 2.5. So the area, all of this area, this white bit, has a value of 5 over 2, or 2.5. All right, but the key here is when you're doing an absolute value integral, you're going to have to look to see what makes the inside 0. In this case, it's 1/2. Understand that part of the graph is going to be the negative of that value when you're less than that number. The other part is going to be the 2x minus 1 when you're greater than whatever makes that 0. And then do this integral separately. Page 288, numbers 23 and 25. All right, good luck. Okay, everybody. So now we're going to look at the mean value theorem of calculus. The mean value theorem says that if you have an integral from a to b of f of x dx, we know that that represents the area under the curve, this blue area that I've shaded here. Well, looking at that, you know, geometrically or visually, you can see that if I draw a rectangle at a certain height, that rectangle should equal that area under the curve. This rectangle, which is the height times the width, b minus a, we call f of c the point, like this height right here. There's f of c right there. That is called the average value of the function. All right. So the mean value theorem and the average value of a function are just two sides of the same coin. We just manipulate the formula. The key part here is the function f of x must be continuous on this interval. If it's not continuous, this does not apply. So a kind of standard question that you would see is, given f of x is equal to root of x minus 1, find the average value of the function and determine the x value c where this occurs. Okay. So write out the mean value theorem. We go, okay. The integral, oh, I didn't give you an integral. Over the interval, that would help, 1 to 10. So that means from 1 to 10, the function, sorry, come on, there we go. x dx. Pause the video. Sorry, peoples. I gotta pause this video. Okay, sorry about that. I had to change the function because I realized we haven't done those functions yet that I had up. So I changed the function to root x. I asked to find the average value of the function and determine the x value where this occurs on the domain 1 to 4. So I changed the domain and the function. All right, so if as soon as I say average value, you know you're talking about mean value theorem, you write this out. Our a's and b's, there's our a, there's our b from 1 to 4. Our function is just root x dx, and that is equal to f of c b minus a, 4 minus 1. All right, that is the average value. That's what we're solving for. So if I divide off the 4 minus 1, I get 1 over 3 integral from 1 to 4. I'm going to rewrite the root x as x to the 1/2 is equal to f of c. So I evaluate the integral to 1/3. You can just pull it out. The antiderivative of x to the 1/2 is you add 1. So that's 2 over 2. So I get 3/2. Divide by that, so it's 2/3 there. Evaluated from 1 to 4. And that equals f of c. So 1/3 leave out. I put the 4 in. 3/2 over 3. Put the 1 in. Equals f of c. 4 to the power of 1/2 is the square root. So square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16. So I get 16 over 3 minus 1 to any power is 1 minus 2 over 3. Okay. 16 minus 2 is 14. 14 over 3. Multiply the 1/3 in. I get 14 over 9 is equal to f of c. That is my average value. And if you look at the graph, here is the graph of the square root. Whoa. Whatever, we'll do thumbs up. Here's the graph of the square root between 0 or 1 to 4, right there. Okay. And if I put in 14 over 9, this point right here will give me the average value, the area under that graph of this rectangle from 1. Let's see if I can do this. From 1 to 4 is equal to the area under the curve from 1 to 4. And you can see this missing bit here is equal to this missing bit here. All right. Second part of that, so that's the average value of the function, 14 over 9. That's the y value. If they ask for c, which I did ask for, I'm asking for the x value. So what is our function? It's root x. So I go 14 over 9 is equal to f of c. So really that's just root c. If I want to know what c is, I just square both sides. Must be square of 14. One sec here. It's 196 over 81, which gives you 2.42 approximately. This is the x value that the average value occurs at. And if you look at the graph, right there, where the okay, y, okay, whatever. Okay, this is bugging me. The x value at that point is 2.4, 2.5. You can see that right there approximately. And if I could tap the graph, it would work, but it's just giving me thumbs up. Anyway, enjoy that. A couple questions I would like you to do are page 288, 45, 47, 51 to 55. Just do the odds, and that'll give you average value and mean value theorem stuff. All right, enjoy your weekend, people. Bye-bye.